Hello, 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 everybody. How are you all? I hope all of you are doing good. I hope straight lines, PYQs, Santosh Ama Santosh Ramba Santosh This is, what is your name, boy? Mumbai Indians Fans Club. Wow. Great. Hanji, how are you all? All good? Having fun? Great. Let's start the next concept chapter, the concept part of circles. And as I have been reminding you from a while, I'll remind once again that we'll be solving the PYQs of circles also in the next week, or I think by Saturday of this week, most probably, right? If not Saturday, then Monday of next week. But before solving the PYQs, I don't want that anybody of you, any one of you, do not go through all the concepts related to the circles or any chapter. We'll do this with every chapter. So we'll have a brief session of the concepts all related for that particular chapter in one session, and then same chapter we will be doing with PYQs of 2002 to 2024, all discussing, solving whatever doubts you have. Wherever doubts you have, you also can do your research, or bring that, sir, I was solving this particular PYQ from this year, this date, and I couldn't solve it. So these things you can also do. Stay engaged, solve along with us, and do your preparation very well. For 2025 aspirants, I know the time is less, but for 2026 aspirants or even later, you have time, guys. You should utilize it right now. The channel and everything, this is a free source, and the teachers which you have on the channel are working for you. So utilize that. Let us know what are your demands. Let us know what do you need right now. If you need any specific kind of strategy videos, we look at your comments and we come, we do things according to your comments. But still, if anything is required, please let us know. Okay, please let us know in the comment section. Soon we'll be giving you the Instagram or other portals also. But so far, what you can do is, in the lectures comment box only you can post your comments, sir, we require this, we require that. Right now we are doing coordinate geometry. In coordinate geometry also, if you need any specific kind of lecture, sir, I want to solve problems specifically of the radical part of parabola, or sir, parametric problems, parametric point problems, sir, I'm struggling with that. So we can take that somewhere or the other. We'll do work for you. All right, we'll begin circles without wasting any time. But one thing which will save your time is this. If you are appearing for 2025, I'll once again remind you, do attend this mock test series. You're prepared, you're not prepared, does not matter, but do attend this test series and make sure that you can be more prepared, better prepared. Without mock test, there is no go ahead in JEE. Without testing yourself, you cannot even expect that you are prepared. You cannot even say that you are prepared. Attempt these mock tests. Okay, very minimal fees and all, everything is there. So do attempt these mock tests, enroll yourself. The link will be in the description. Link is in the descriptions of all the sessions that we are taking so far. Do attend these tests. Okay, now circles. Let's begin with circles. Okay, so what we have studied straight lines. I hope that straight lines now is up to the mark for you all, is okay for you all, and you all are very familiar and very strongly confident with straight lines now. If you're not, then do that once again. but be very, very good with entire coordinate geometry. It's an important part of JEE. It's an important chapter or section of JEE. Now about circle, we did a lot of questions based on locus, right? We did a lot of questions based on locus. Circle is also nothing but a locus. Circle is also nothing but a locus. For example, suppose I have suppose this is my coordinate axis. Okay, and this is my center. Now there is this point, this is the origin. Now there is this point which is, let's say, x1 comma y1, or we generally take h comma k for a circle, right? For h comma k for the locus. So now what do I want? I want that the distance of this particular point always remains same from this point, which is called the center. Okay, so we can easily find the locus. Locus only, see, in 9th, in 8th, in 10th, we have done a lot of properties of circle. We know that, okay, circle is a point which moves at an equidistant from a fixed point. We know the properties of circle. We know the properties of tangents and so many things. But mainly now we need to understand circle with equations, with conditions. Now we'll not have construction or geometry based problems. In JEE, we don't have geometry based problems on circles. Geometry will be required, but more of conditions will be required. So now in this part, pay attention on the conditions. So very simple thing, how do we understand that, sir, a fixed point is, a point is moving in such a way that its distance from a fixed point remains always same. So I say that, let's say that distance is r, which we also call radius, and I'll simply say, sir, from distance formula, I'll find the distance. Sir, h minus 0 whole square plus k minus 0 whole square is going to be equal to r. And when I take square both the sides, I'll get h square plus k square is equal to r square. And now this h comma k, because this is locus, this is a moving point in the coordinate plane, I'll just replace my h comma k with x comma y, and I'll say x square plus y square is equal to r square. This is my main basic equation of a circle. Okay, this is my equation of a circle. Very basic equation of circle whose center is at origin. Now sir, if center is not at origin, if center is, let's say, some point x1 comma y1, then I'll say, okay, my point h comma k is moving in a such a way that it is equidistant from x1 comma y1. So I'll simply say h minus x1 whole square plus k minus y1 whole square is equal to the radius, which is this distance, which is always fixed, is equal to r square. And here also I'll do the same thing. Instead of h comma k, because I'm talking about locus, I'll again replace it as x and y. So x minus x1 whole square plus y minus y1 whole square is equal to r square. Now for this one, my center is at x1 comma y1. Now center is not 0 comma 0. Now my center is not 0 comma 0. Center is x1 comma y1 over here. So this is how, if see, first part of entire coordinate geometry, most important part is straight lines. After that, everything is a problem. Once you have understood locus, basic things about straight lines, everything, all the curves are just problems for you now. Think of them as problems. Okay, think of them as problems. All right. Now, so we are clear that if the center of the circle is x1 comma y1, then I can write the equation of that circle as x minus x1 whole square plus y minus y1 whole square, and that will give me, that will be equal to r square, which will be the radius of the circle. This is how you are supposed to think now. So from now, one basic fundamentals you understand. After that, every chapter should look to you, everything in mathematics should look to you like a problem. Derivations, everything, if you think of it as a problem and start solving it, you won't have to actually remember any formulas. Otherwise, you'll have to always rely on the formulas. Right now, here although JEE Mains or JEE Advanced, anybody except the boards are not going to ask you a question based on this. But let's say they can make a question that the center of a circle is 2, 2, and the circumference is equal to, let's say, we'll have to 4 pi. Okay, let's say circumference is 4 pi. Okay, now what will be the equation of circle? So what do you need to make the equation of circle? You need center and you need radius. That's it. What do we learn from here? That, sir, for making any writing any equation of a circle, we need center and the radius, nothing else. All right, so in this case we have the center. How will we get the radius? We know circumference is 2 pi r, that will be equal to 4 pi. Pi cancelled, 2 cancels to r is equal to 2. So we can simply write x minus 2 whole square plus y minus 2 whole square is equal to 2 square, which is 4, not 2, square of radius. Right, basic small things, just that. Okay, so now and few properties, that diameter or radius both of the circle will pass through the center. Right, small things, if small properties of circle, if you keep remembering, you will be able to solve all the problems. There won't be any problem in that. Right, there won't be any problem in that case. Now let's say they can give you a problem like this also, that there are two lines, right? Both the lines are diameter of the circle and the area of the circle is given to you something. Let's say two lines are there, 4x minus 7 plus 8 is equal to 0 is one line, and 2x minus 7y minus 3y plus 4 equal to one line. Both of these lines are diameter of a circle. Both of, like, diameters of the circle lie on both of these lines. A circle can have n number of diameters. There can be many diameters. So how will you solve? So you'll simply find the midpoint, intersection point of this. Right, you can simply find, and one more information, something like area or perimeter will be given to you. They'll give you area or perimeter also. Right, so to find the radius, so radius and intersection point of diameters intersect only at one point, which is the center. Diameters always intersect at the center. Will you start 12th portion after Feb or March? We'll start 12th portion by March mostly, March first week mostly. Right, most probably March first week. Okay, please keep the be subscribed on the channel and get more subscribers and also hit the like button whenever you are here. Okay, I don't have to remind you. Center with circle, yeah, one thing, that this equation is only with the center 0, 0. Right, all right. So what kind of problems they can give you on this part? They can give you two lines which are on diameters. Find the intersection point, because diameters will always intersect at a single point. That point will be the center of the circle. Center and radius are the two things that you need for finding the equation of the circle. Or how else can they give you a problem? They can give you radius and they can say that the center of the circle lies on some point. Right, they can say that center of the circle lies on some point, and circle also passes, for example, they can say that there is a circle which passes through a given point, let's say 2, minus 3, and they can also give you that center of the circle lies on some line. There is a line on which the center of the circle lies. Okay, they can give any equation, let's say y is equal to x minus 1. Right, they can give you like this. And what else can they give you? They can say that radius also they'll give you in this case. Radius also they'll have to give you in this particular case. Let's say radius is 3 units. Now this kind of problem also, how can you solve? Center of the circle lies on this point, so assume this point. Assume this point. It's very easy to assume this point. If you take x as a, suppose x coordinate of center is a, then y coordinate of center will be a minus 1. Correct? You can easily assume this point. Then this distance between this given point and this point, you can equate it equal to the radius. So now every problem you'll have to think from which part they are asking, right? From which part they are asking. That's one thing. Now next part which comes is okay, one more type of problem we can take. They can also give you something like this, that there is a circle which passes through 2 points. They'll give you 2 points, let's say 2 comma minus 3 and 4 comma 8 or something, right? I'm randomly taking and I'm telling you how, or wait, 1 2 4 comma 8 bahut zyada, too much it will be. Let's take 1 comma minus 2 and what can we take? 4 comma minus 3. Let's take 4 comma minus 3. Okay, they'll say that the circle is passing through these 2 points and the equation, we'll have to find the equation, and they'll also give you the equation of line which is passing through the center, right? Equation of line which is passing through the center, that also they can give you. Let's say this is some equation of line which is passing through the center. Equation of line which is passing through the center, let's take x plus y equal to 2. Let's take this line, not necessarily this line only, it can be anyhow, it can be here, anywhere. Now they'll say that find the equation of circle. So again same thing, right? You'll assume this point, make this distance equal to this distance. Assume this point because this is passing through the center. So any assumption you can make. If you take x as a, x coordinate as a, y coordinate will be a minus 2. So this distance will be equal to this distance and you'll be able to find a, right? So different type of problems they can take you. But one more thing which you can always think, always remember that if a circle is passing through 2 points, right, and center is known to you, right? If a circle is passing through 2 points, very important property of circle, suppose center is known to you that a comma a minus 2, right, here only, and circle is passing through 1 comma minus 2 and 4 comma minus 3, right? Before attending the PYQ session, please go through all these things, try to do all these things on your own so that you'll be able to solve the PYQs better. Although we try to give all the solutions and explain there also, but still basics should be thorough, basic formulas, basic concepts should be thorough with everybody. Now what you can think, simple property of circle which we learned in our previous classes 8, 9, 10, that from center if we draw a perpendicular to a chord of the circle, then by congruency we can prove that this chord will be bisected by the perpendicular from the center. If we draw a perpendicular from center to any chord of the circle, then that perpendicular will be bisecting the circle. Why? The reason is that this particular triangle and this particular triangle will always be congruent, and that's why these sides will be equal, right? And it will be perpendicular, right? So one thing which we can do, midpoint we can find. What is the midpoint? 4 plus 1, 5 by 2, and minus 3 minus 1, minus 3 minus 2 minus 5 by 2. Okay, right? Minus 5 by 2 and 5 by 2 and minus 5 by 2 will be the coordinates of the midpoint of this chord, correct? And when we connect the center with this midpoint, it will definitely be perpendicular. It will definitely be perpendicular because from center the line which is bisecting the chord will be perpendicular to the chord from center. From here we can use the concept of straight lines. Slope of this line into slope of this line will be equal to minus 1. That how also we can find a. For example, here if I do minus 3 minus minus 2, that means plus 2, divided by 4 minus 1, which is y2 minus y1 upon x2 minus s1 x1, slope of this line, multiplied with slope of this line. This line slope also we can find 5 by 2 minus a minus 2 upon minus 5 by 2 up minus a. This product will give us minus 1. Here also we'll get the value of a. Same answer will come in both the scenarios. But remember these things. Know these things. Acha, this will be perpendicular to that. Just a minute. This will be perpendicular. So one relation is this also. This is also one relation where will draw a perpendicular from center on the chord, and that perpendicular which will be will have negative slope, right? Suppose in some case you know the equation of the chord and you want the equation of line passing through the center, so it will be negative reciprocal. So these things you'll have to grow and develop while solving the question, and you have to know these things. You'll have to know. Okay, now this is one type of equation of circle. Okay, this is one type of equation of circle. Now suppose if we open this thing, if we open the general equation, x minus x1 whole square plus y minus y1 whole square equal to r square. If we open the squares everywhere, what do we get? X square plus x1 square minus 2x1 minus 2xx1 plus y square plus y1 square minus 2y1. Thoda sa let me reduce the density of this pen so that we can write more. Equal to r square. All right. Now I know the general equation of 2 degree. General form of 2 degree, standard equation of 2 degree, which is given like this: x square plus y square plus 2hxy plus 2gx plus 2fy plus c equal to 0. This is my general 2 degree equation, right? This is my, if you have studied, if you'll just how do we derive this, that also I can tell you. If you multiply a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, if you multiply these, right, and if you get all the terms, how will you get? a1 a2 x square, right, b1 b2 y square, something like that. One term of xy you will get, one term of x you will get, one term of one constant you will get, c1 c2. So when you will multiply, so the common coefficients, if you start calling them, ax square plus by square plus 2hxy will come plus 2gx will come, 2gx will come plus 2, okay, that's it, 2gx plus 2fy will come plus c will be equal to 0. So you'll get a y square term, a x square term, an xy term, an x term, a y term, and a constant term. When you multiply these, that's what is called general 2 degree equation, right? Something like this you will get. And there also, right, this is your general 2 degree equation. A and b I forgot to write. All right, a and b will also be there in this general 2 degree equation. Now if we compare this with the this equation which we are getting, and let me arrange these also: x square plus y square minus 2xx1 minus 2y1 plus x1 square plus y1 square, okay, minus r square equal to 0. If I write it like this, same thing I've just arranged. Now look at this, and if we compare it with that, right, ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. If I compare these two, what do I find? Very hot it is becoming. What do I find? One thing, that a is equal to b. A is equal, it's not correct saying A and B are 1. We don't say that A and B are 1, because if these two are equal, if these were 2 also, then I'll just divide the entire equation with 2 and they'll become 1. Right? In this case it was, even if we'll multiply this equation with something, it will remain same. So it's better to say that A is equal to B instead of saying that A and B are equal. I'm sorry, instead of saying that A and B are equal to 1. Right? So what do we say? In circle, if we see every curve, every conic which we are going to study, straight lines, the product of a pair of straight line will be represented by this. Circle, when this is there, right? H square minus AB, if that is greater than 0, then one curve H square equal to AB, then one curve H square minus AB less than 0, then one curve. Parabola, ellipse and hyperbola, everything is related to this only. For circle, there is a specific condition that in this case, if we get A equal to B and our H is equal to 0 in the general equation, because there is no xy term. Do you see any xy term? No, there is no xy term in case of circle. So H is equal to 0, A equal to B will always give us a circle. Right? If general equation is given to you and they ask you that what is the condition, what if an equation in general format is given to you, right, and what if they ask you that if this condition represents a circle, then in that condition just do these two things, A equal to B and H equal to 0, and you'll get the condition for circle. Now here, what points do we need to understand? What points do we need to understand? Acha, 2H, right? Now this, if we compare these two, then can I say that my 2H is equal to my 2H over here is equal to minus 2x x1. So can I say H is nothing but minus of x, not 2x x1, 2x1, right? H is nothing but minus of x1, or x1 is nothing but minus of H. And similarly, can I say y1 is nothing but minus of G? What was my x1 and y1? My x1 and y1 was my center. X1 comma y1 was my center, and here I am just comparing it with the H and G. So x1 is nothing but H and y1 is nothing but G. Now if an equation is given to me in the normal format, in the big format, not like this, right? It's given to me somewhere like this. Let's say some equation is given to me that there is a circle x square plus y square plus 4x minus 8y plus 7 equal to 0. This is my circle, let's say. Okay, this is my circle. This is how an equation can be given to you, that this is also representing a circle. Why? Because x and y are equal, right? And xy term is not there, so H is equal to 0. But here, how will I find my center? In this case, how will I find my center? So very simple. I know that my 4, which is 2G. My 4 is what? From the normal equation, if I compare, my 4 is what? 2G, right? My 4 is 2G. So this is 2G. That means G is nothing but 4 by 2. And I know x1, that means center is minus G, that means minus 2. Right? And I know y1 was nothing but minus of f. What will be f? Minus 8 by 2. Sorry, here already minus. So my 2f will be equal to minus 8. Correct? 2f will be equal to minus 8. So f will be equal to what? Minus 4. What was my center? What was my center? From here, what am I getting my center as? Sir, x1 is minus h, y1 is minus g. So minus g, that means minus 2 is my x1. This is minus g. And what is my f? Minus 4. So my minus f will become 4. Minus f will become 4. Right? Minus f will become nothing but 4. This, if I do minus f, so minus f will become nothing but 4. Right? This will become nothing but 4. Getting my point? So if this equation, this type of equation is given to me, what I need to do is, for center I know my center will be my center will be always minus g comma minus f, because when I compared it with this one, I got that x1 is minus h and y1 is minus g, right? X1 is minus h and y1 is minus g, correct? So center I am getting over here, but general equation is like this. General equation is like this. 2x1. How did I get it? How did I get it? Like this. Like this. Right? In the general equation, what will be multiplied? Minus 2 will be multiplied. In the general equation, minus 2 will be multiplied, right? In the general equation, minus 2 will be multiplied. Now, let's take some more example. Let me give you a simple example. Let's take okay, we'll take two examples. X square plus y square plus 4x plus 4y minus 28 equal to 0. Let's take this. Now what is the center of this circle? Now how do we understand that what is the center of this circle? Simply take this, right? Simply let me do a minus over here, right? Let me do a minus over here. Simply take this. What is your this thing? According to normal equation, 2gx, right? You know, normal equation of circle will be x square plus y square plus 2gx plus 2fy plus 2gx plus 2fy plus c equal to 0. This is your equation, general equation of circle, right? No xy term, a equal to b, and this is your general equation of circle. Now in this only your 2gx, your 2g is equal to 4 over here, right? Your 2g is equal to 4 over here. So g will be equal to what? 2, correct? And your 2f is equal to minus 4 over here. So f will be equal to minus 2. Now you know what is the center? We derived, right? What will be the center? Center will be minus g comma minus h. x1 comma y1. So minus g comma minus h. So here your center will become what? Minus 2 comma minus of minus 2, that means 2. Right? G is minus 2, f is 2. What is your C? C is minus 28 only. C is not a problem. C is minus 28 only. Okay. Now suppose in case you have an equation where x square and y square have a coefficient. X, let's say 2x square plus 2y square plus 3x plus 4y minus 7 equal to 0. First of all, tell me, can we write 3 over here? No, we cannot write 3 over here, right? We cannot write 3 over here. A and B should be equal for it to be a circle. So that means this will be equal. A and B, x square and y square coefficients will always be equal. That is for sure, without any doubt. That is for sure, without any doubt. Right? Now, first you make the coefficients equal, then compare the circle, because you know for general equation. General equation, I'll write once again over here, x square plus y square plus 2gx plus 2fy plus c equal to 0. This is your general equation. So first bring it in general equation. Okay. Now x square plus y square, if we are dividing by 2, it will become by 3 by 2, x plus 2y minus 7 by 2 equal to 0. We'll divide entire equation by 2. Now again, 2g is equal to 3 by 2, g is equal to 3 by 4. Minus g is equal to minus 3 by 4. Right? 2 is equal to 2f. So f is equal to 1. Minus f is equal to minus 1. So center will be minus 3 by 4 comma minus 1. Right? So just remember, in this equation, center will be equal to minus g comma minus f. Now about c, we didn't look at c. What is this c equal to? C equal to this entire constant term. So c is equal to x square plus y square minus r square. Right? We can also say r square is equal to x square plus y, x1 square plus y1 square plus minus c. Right? We can say r square is equal to x1 square plus y1 square minus c. R will bring there and c will move there. So we can simply say my radius will also be equal to square root of x1 square plus y1 square minus c. What is x1 and y1 again? I know x1 and y1 are nothing but my center. So square root of minus g square, that means g square, plus minus f square, which is f square, minus c. This is my radius. This is my radius. This will be my radius. So in general equation, if I want to find radius, I can find radius. I can find center also. If I center and radius, most of the problem is solved for me. Now here on this thing, this particular variety, this particular equation and derivations from it, you need to remember to solve the problems. On this particular thing, that find the radius, find the center, they won't make any problem. But from this equation given in this form, you should be able to find the center and the radius. That's the catch. You should be able to find the center and the radius if equation of circle is given to you in this form. That's it. Nothing major. In this form, if the equation is given to you, then you should be capable of finding the radius and center with the help of this particular equation. That's the motive, right? So this is general equation. From general equation, simply, although you should not remember that, sir, center will be half of x coefficient and minus of that. That's not the correct way. You always should, because if you remember, they'll twist the story in that particular scenario also. But if you remember the concept, you know that general equation, just keep it in your mind: x square plus y square plus 2gx plus 2fy plus c equal to 0, right? And you know this is going to be the scenario. You can remember that center is minus g comma minus f. Just remember, center will be minus g comma minus f. Radius will be square root of g square plus f square minus c, right? If you remember this way, then you'll always be able to deduce your things very easily. Now let's say they give you a question. Here one particular question can be made. They'll give you 3 points, and we know a property that from 3 points, from 3 non-collinear points, there can be only one circle which passes. This we have learned in our previous classes. Hi Anirudh, hi Ravi, how are you? Sir, you will start 12th portion after February, March. Okay, I answered that. So I was saying that from any 3 points, only from any 3 non-collinear points, only one circle can pass. Now let's say if they give you points like 5 comma minus 8, let's take 3 points, 5 comma minus 8, okay, 2 comma minus 9, and you take one more point as 2 comma anything, any 3 points randomly also you can take. I'm just trying to make this calculation simpler, right? Let's say these 3 points. You take any random 3 points, there always will be one circle passing through them. Now, but how to write the equation of that circle? How to write the equation of that circle? One method says that you write the general equation: x square plus y square plus 2gx plus 2fy plus c equal to 0. And then you satisfy all the 3 points. 5 comma minus 8 you satisfy, 2 comma minus 9 you satisfy, and you satisfy 2 comma 1. So in this case, 3 variables will be there because you are satisfying. So x and y will take these value. Only g, f and c will remain. And then you can solve for g, f and c. That is one approach, right? In most of the books also this approach will be there. But we know, if we have studied circumcircle, if we have studied straight lines, and we have the information of circumcircle, we know that from 3 points, and we have in PYQ session, if you have attended, then there were many problems on circumcircle. That is the reason straight line, circle, parabola, hyperbola, everything is foundation is straight lines. So do straight lines first properly. Okay, 2 comma minus 9 and let's say 2 comma 1. Right, 3 points are there which are given to us. Now what do we know? that circumcircle is a circle which passes through the three vertices of the triangle. So basically, three non-collinear points will form a triangle only, and from that triangle, the three vertices will form a circumcircle. Now, what do we need? Here we need center and the radius. That means circumcenter and circumradius. Two things we need: circumcenter and circumradius. Solving like this method can also be used. You satisfy these, make three equations in G and F and C, and then find G, F and C. One more approach is, and this is better approach in fact, I would say this is in fact a better approach, right? You say that, okay, center is alpha comma beta. Let's say center is alpha comma beta. Now whatever is your this thing, whatever is circle, the circle which will pass through these, let me make a arbitrary circle, right? Center of the circle will be this only. Circumcenter means this center. Now if I draw a perpendicular from center, it will bisect the chord. It will bisect the chord. So this point will be what? 5 plus 2, 7 by 2, comma minus 8 plus 1, minus 7 by 2. Right? This point I got. Similarly, if I draw perpendicular over here, bisecting this chord, so this point also I can find 7 by 2 and minus 9 minus 8. 5 plus 2, 7 by 2, minus 9 minus 8, minus 17 by 2. Correct. Now what I can do? I can just do the slope thing. I can just compare the slope. Right? Here also I'll get two equations in two variables. What will I get? Slope of this, that means minus 7 by 2 minus beta divided by alpha minus 7 by 2 multiplied with this slope, which is minus 8 minus 1 minus 9 and 5 minus 2, that means 3. This will be equal to minus 1. From here I'll get one equation in alpha and beta, and the same thing I can do here also. Slope of this, that means minus 17 by 2 minus beta divided by 7 by 2 minus alpha. This multiplied with the slope of this, that means minus 8 plus 9, 1 divided by 5 minus 2, 3. This will be equal to minus 1. From here I'll get one equation in alpha and beta. Although pain is equal, but you should know both the approaches depending on what is given to you. Right? This concept of perpendicularity will be used very often in the entire coordinate geometry. Correct? One method can be this, one method can be this. Right? Now circumradius, to find the distance of center with any of the points, it will be equal only. It will be definitely equal only. Okay. So this is one approach which you can use. Now, rest are, these things are examples which we already took. The diameter of the normal of circle passes through its center. General 2-degree equation in two variables is represented like this: ax square plus 2hxy by square plus 2gx plus 2fy plus c. Just now we studied, right? And in circle, h will be 0, a will be equal to b. This is what we understood just now. The notes are going to be there with you. You can revise, and you should revise before attending the PYQ session. These examples we took already. These examples we have taken. Okay. This thing is important, right? Remember these. You cannot always, radius formula, square root of g square plus f square minus c. Okay, these things are small things but important. Some special kind of circles. Suppose if a circle is touching the x-axis at a comma 0, right? At a comma 0, and its radius is given as r. Then what will be the coordinates of center? A will be the x coordinate, obviously. A will be the x coordinate, same. Then what will be the y coordinate? Y coordinate will be r. Right? A will be the x coordinate, y coordinate will be r. Can you see that? What will be y coordinate? By this is a comma 0. So if I draw a coordinate axis over here, this distance will be a. Right? This distance will be a. What will be this distance? This distance will be r. So x, y, y will be r. Y coordinate will be r. X coordinate will be a. In this case also, you can formulate that. In this case, y-axis is made. So let's say x-axis we are making, coordinate axis, it is touching the coordinate axis, it is touching the x-axis, but obviously if it is touching the x-axis, y coordinate will be there, no, somewhere, right? So this distance r, now on y-axis this distance is r, right? On y-axis how much higher this is? B, because y coordinate is b. So this distance will be, this distance will also be equal to r. What will be the x, what will be the coordinate over here? The x coordinate is 0. The x coordinate is 0. What will be y coordinate? 0 comma b comma, sorry, r comma b. X coordinate will become r from here to here, and y coordinate will remain b only. Right, this distance will become r, it is at b height. Same over here, let's say this is r, right? This is r. What is it? Circle touching x-axis at origin. X-axis at origin, that means this is 0 comma 0, right? This is 0 comma 0 touching the x-axis at origin. So this distance is r. Simply y coordinate will become 0 comma r or 0 comma minus r. Circle touching y-axis at origin. If at origin it is touching y-axis, then coordinates will become r comma 0. So these things you can formulate according to your coordinate geometry knowledge. Nothing major you need over here. Acha, theek hai, one question let's discuss over here. One question we can discuss. This question is from advanced 2021. There is a, I'll tell you the question, I didn't bring, there is a triangle whose two sides lie on x-axis and the line, right? There is a circle, there is a triangle whose two sides lie on x-axis and the line x plus y plus 1 equal to 0, right? Two sides, one of them lie on x-axis, one of them lie on this line, and the orthocenter is given. If the orthocenter is at 1 comma 1, orthocenter of the triangle was also given, which is at 1 comma 1. Then what is the equation, and they asked the equation, the language I don't remember, but what is the equation of circumcircle, something like this, or they'll give you what was the equation of circle which is passing through the vertices of this triangle. What is the equation of circumcircle? Something like this was asked in JEE Advanced 2021, and it was a multiple choice question, right? But we could solve this question with whatever knowledge which we have gained till now, right? So now what did they say? They said that two of the sides, one of them lie on x-axis and one lie on this side. So this is x-axis, let's say. This is my another line which is x plus y plus 1 equal to 0. Okay. So on x-axis point lie, let's say this point is alpha comma 0 and this point is beta comma 0. Both are on x-axis because one side is this. Now can I find this point? This point I can find because this point is also lying on this line. So this point is where y is 0. When y is 0, x will be equal to minus 1. So I can say this is minus 1 comma 0. This is minus 1 comma 0. Correct. Orthocenter was also given to me. Orthocenter is 1 comma 1. Okay, orthocenter is 1 comma 1. What can I use over here? This slope. The orthocenter means from vertices, if we draw perpendiculars, the all three altitudes intersect on the orthocenter. So if I draw an altitude over here, let's say, so what will I have? 0 minus 1 divided by alpha minus 1 multiplied with slope of this line, which is minus 1. Minus 1 equal to minus 1. Correct? So this gets cancelled. Slope of this multiplied with slope of this will be equal to minus 1. Right? Slope of this line multiplied with slope of this line will be equal to minus 1. From here I can get alpha also. Right? So what will be my alpha? What will be my alpha? Alpha minus 1 equal to minus 1. Na? So alpha will become 0. This point will be 0, 0. 1 point is 0, 0. 1 point is 0. 1 point is minus 1, 0. Right? Now, what about this point? Now, this point also I can find using the same condition. Let's say this point is alpha, not alpha. This time t. Right? This point lies on this line. So t, if x I take as t, what will y become? Y will become minus t minus 1. Correct? If I take x as t, then y will become minus t minus 1. So minus of t plus 1 I can write. X comma minus of t plus 1 I can choose. Now same thing I'll do and I'll find t also. I know that minus t plus 1 minus 1 divided by t minus 1. Slope of this multiplied with slope of this. Slope of this is what? 0 only. Slope of this is what? This is x-axis, so slope is 0. Is equal to minus 1. No. Something wrong we are doing. This is 0, 0. Points I took wrong. Kya? That we cannot do. Right. We cannot do that only. I think I took the points wrong or the line wrong. Something is wrong over here. Maybe I couldn't remember the question correctly, but something like this only. Okay, sir. Okay. T, wait. Slope will become infinity, na? So t minus 1 will become 0. So t will be equal to 1. That way also we can solve. But this will be actually y-axis, because line perpendicular to this, that one way of thinking is line perpendicular to x-axis will have slope of infinity. If slope is infinity, then this denominator will be equal to 0. So t minus 1 will be equal to 0, t will be equal to 1, and point will become 1 comma minus of t plus 1. That means 1 comma minus 2. This point will be minus 1 comma minus 2, but you'll have to think a bit differently. Right? This slope of line perpendicular to x-axis is infinity. When will this term become infinity? When t will be equal to 1. I'm just thinking any other way we could think of this, then it will be good. We can think from here. We can think from here actually. Right? Slope of this will be minus 1 upon minus 1 minus 1. That means minus 2. Slope of this particular altitude. Right, multiplied with this slope, that means minus of t plus 1 divided by t. This will be equal to minus 1. Right, this way also we'll get t equal to 1 and point will become 1 comma minus 2. Right, but you see, advanced also asked question on orthocenter perpendicularity. This is not the question of circle, because once we get 3 points, we have both the methods just now which we see, right? We saw 2 methods for solving this type of question, na? We saw 2 methods. Either we can satisfy these 3 points in this equation, or we can use this particular method. We know both the methods for solving this type of problem. But yeah, from this part, these type of problems can be asked. So here till now we are just using straight lines concept only and little bit of concept of equation of circle, right? So equation of circle should be very thorough, and the center and how to find the radius, that should be very thorough. Now let's move to the second point, diameter form. Diametric form, it's very simple to understand this also, that suppose if I have a circle. Now one form which we learned is center radius form, x minus x1 whole square plus y minus y1 whole square is equal to r square. Then we saw general form, x square plus y square plus 2gx plus 2fy plus c equal to 0. In that, center is minus g comma minus f and radius is square root of g square plus f square minus c. Now diametric form. Diametric form says that if you know the two endpoints of the diameter, suppose I give you a circle and I tell you the two endpoints of the diameter. x1, y1 is one endpoint and x2, y2 is another endpoint. Then in this case, how will you write the equation of circle? This one is also very important. Sometimes it is used specifically. Now suppose these two are endpoints of my diameter. So let's say now I want to write the equation of circle. Let's go back in the starting. What did we do? How did we form the equation of circle? We chose a point x1 comma y1. We fixed its distance, we chose a point h comma k and we fixed its distance from a fixed point x1 comma y1. So h minus x1 whole square plus y minus y1 whole square was equal to r square, and then h comma k we replaced at x and y, so we got the equation of circle. Here but there is not such scenario, no? Here there is no such scenario. What can we do? We can say that okay, this point is h comma k. Here perpendicularity will be used, and then we'll say if we connect this point h comma k with both the ends of diameter, then we know that every point on the circumference of the circle subtends 90-degree angle at the diameter, right? Every point on the circumference of the circle subtends right angle at the diameter, or no, ulta I said reverse. Diameter subtends 90-degree at every point on the circumference of the circle. This is one property that we know, that if we connect the two endpoints of diameter with the periphery of circle, any point on the periphery of circle, then that will subtend 90-degree. That means this angle will definitely be 90-degree. And if this angle is 90-degree, then what I can do, I can say that this slope, that means y1 minus k divided by x1 minus k will be equal to, multiplied with this slope, that means y2 minus k divided by here h, right? x1 minus h, x2 minus h will be equal to minus 1. Product of these two slopes will be equal to minus 1. And as soon as I solve this, we can also solve this over here also. So let's say y1 minus k into y2 minus k equal to minus of x1 minus h into x2 minus h, and then I'll replace h and k with x and y. So what will I get? X minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. This is my diameter form. This is my diametric form or diameter form. When endpoints of diameter are given to me, then I can write the equation of my circle simply like this, right? I can simply write like this. If the endpoints of diameter are x1 y1 and x2 y2, then equation of my circle will be written like this. Very important form, sometimes very useful, sometimes very very useful. So know this also. We'll be using this in the question session. We'll be using all of them. In fact, in the sessions we'll be solving questions, but for now just keep revising these things. I'll try to derive and formulate everything as much as possible so that you remember these things. Okay, here question. Here one question which was asked in mains only was something like this, that find the equation of circle which passes through, the points were some 1, 0 and 0, 1, which passes through 1, 0 and 0, 1. Right? These points were given. This is a mains question only. Find the equation of, here they'll just try to tell you or let you know that how can you think that it is a diameter or not. Right? Question was something like this, find the equation of circle which passes through 1, 0 and 0, 1 and has its radius as small as possible. By radius as small as possible, how? Because suppose if 2 points are there, suppose these 2 points are there, okay, these 2 points are 1, 0 and 0, 1, suppose, then my radius, my diameter will be greater than this, na? My diameter will be greater than these 2 points, correct? This distance. So radius will also be greater than this distance, correct? Radius as small as possible means diameter as small as possible. If I want a circle to be passing through these 2 points and I want its diameter to be as small as possible, then I should keep these 2 points as diameter and draw a circle. Then only my diameter will be as small as possible, na? Otherwise diameter will be bigger. So there the catch was, in that question only the catch was that you have to take these 2 points as the end points of the diameter and write the equation of circle, which will be x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. That's it. Diametric form. Please don't forget to hit the like button if you are there in the session. Okay, diametric form, sometimes when you are able to find a relation between endpoints of diameter, this form will be very, very useful. We'll see in a lot of questions which we'll be solving. Okay, now comes parametric form. Bhai, parametric form is useful when you have to assume a point on the circle. Suppose assuming a point, sir, why do we need to assume a point? If we want to assume a point, we have the equation. We can assume as we want. Sir, if the equation is x square plus y square is equal to r square, can't we assume as x1 comma square root of x square minus r, or r minus r square minus x square, r square minus x1 square? We can do this also, no? Why to assume a point? But solving with this will be very difficult. So there is a way of assuming correctly, which is called parametric point. Parametric point, or sometimes they'll give you in parametric form, they'll give you in theta form, right? They'll give you a question itself in the theta form. Then what will you do? So they say that if from, this is x-axis, let's say, let me draw the axis also over here. This is y-axis, this is your y-axis, this is your x-axis, and this is some point, right? Now, if this point is at theta angle and your center, let's say, is 0, 0, because here we are intersecting x and y. So let's say center is 0, 0. Okay, let's say center is 0, 0. Then what will be this point? You know from straight lines, one thing to you know from straight line, any point which is at r distance from a given point, its coordinates will be x1 plus r cos theta. This radius is r, na? Right? You know, we studied in straight line, no? If there is a point x comma y and there is a point x1 comma y1 and distance between these 2 points is r, and the angle, the direction in which this point is the direction is given by theta, then you know how to write. You know x1 will be x plus r cos theta, and you know y1 will be y plus r sin theta. So here x comma y is 0 comma 0. So this point will become nothing but r cos theta comma r sin theta. You can simply take this point. Otherwise also, if you want to just do this thing only, then you know that this is theta, this is r, right? This coordinate will become r cos theta, this coordinate will become r sin theta. That way also you can think as you want. Correct? But correct way is to relate it with the straight line parametric form, right? Straight line parametric form, it's better to connect it that way. This is not normal form, that was cos alpha. That's why in books also they use different parametric form. Any point which is at r distance in theta direction from a given point will be written as x plus r cos theta, y plus r sin theta. So here also we are doing that. Suppose if I change the center, suppose the center is not 0 comma 0, suppose the center is alpha comma beta or x1 comma y1, then this point will become nothing but x1 plus r cos theta, y1 plus r sin theta. Okay, so point forms are different, but everything is related, and try to relate that. Trust me, try to relate that. Right? Try to relate that with entire coordinate geometry. If you keep studying, if you keep understanding by relating one topic to another, no, it will be very interesting. René Descartes, the mathematician who founded this thing, was so amazed by his discovery that this is so beautiful, so systematic, everything is connected. I'm able to connect everything. There is a book written on that. I'm not able to remember what name was it, but René Descartes' kind of biography or his experiences on coordinate geometry is written down in a book, and he says that it is so, if this entire world, he said that if this world is actually made by God, then God must be a mathematician, then God must be a very good at math, because everything is systematic, everything is connected, relatable. We don't do that. We try to mug up everything, but everything is connected. Okay. But obviously we have to pass the exam. We cannot keep on deriving everything. Some things we'll have to mug up also, some things we have to keep remembering also. Okay, so this is diametric form. Basically it is the sum of two quadratics. Very good. This is one thing we should remember, right? This is one thing we should remember, that actually what does it look like? These are two quadratic equations whose roots are x1 y1 and x1 x2 and y1 y2. This is actually just two quadratic equations whose roots are x1 y1 and y1 y2, x1 x2 and y1 y2, isn't it? That thing only is written, no? So this can be some x square plus x square plus bx plus c, and this can be some y square plus dx plus e. Correct? This is nothing but a quadratic equation whose roots are, factors are x minus x1 and y, x minus x1 into x minus x2 and y minus y1 and y minus y2. So sometimes they might make a question like this, right? That the roots of this quadratic equation are satisfying a circle, and roots of another quadratic equation are also satisfying a circle. Then what are the endpoints of diameter? Then you have to connect all these things. Although we'll see these type of things while solving questions also, but remember all these. Okay. Hi Tanisha. Okay, so this is one thing, right? All these notes, although circles lecture is already taken on this channel in detail also, but here I'm just revising things for the PYQ session, which very few people are attending. I don't know why. If you want the time to be rescheduled or time to be squeezed, if you want less PYQs to be there, you can comment on it. Last time I took somewhere around 175 PYQs, and it took me 12 hours to complete the class. So we'll have to reduce them a little bit, and accordingly. But yeah, this is all for you guys. Okay, nobody else. All right. So this is one thing, parametric form, right? Okay, next thing, AB intercepts made by the circle. By we know x square plus y square plus 2gx plus 2fy plus c equal to 0 is my general equation of the circle. Now I am saying that my circle is cutting the x-axis at 2 points. Okay, or my circle is cutting this thing is different. I'm just saying that if my circle is cutting the x-axis at 2 points, if circle is cutting x-axis at 2 points, let me take it on a different page. Intercept on x-axis. Okay, if my circle is cutting x-axis at 2 different points, then how will I find the intercept, length of intercept made, or the intercepts itself on the 2 points? How will I do that? That is the question. Any suggestions? By intercept made means क्या हुआ? What is the meaning of intercept made? A line is cutting the circle, and intercept is the length, this length. We are talking about this length. So I am saying that intercept made on x-axis. If my circle is cutting the x-axis at 2 different points, then what will be the intercept made? Here x-intercept. How will circle make x-intercept and y-intercept otherwise? Right? Length of intercept we are talking about. What will be the length of intercept made? Okay, so if I take the general equation, let's say x square plus y square plus 2gx plus 2fy plus c equal to 0, and I know this circle is cutting x-axis at 2 different points, then on both the points y will be equal to 0, kya? Right, x-axis at 2 different points, that means at both the points y will be equal to 0. So I'll make y equal to 0. What will I left with? X square plus 2gx plus c equal to 0. Correct? This will come. If y is equal to 0, then this equation will come. Right? If my circle is cutting x-axis at 2 different points, on both the points y will be equal to 0. Equation will become this. Now in this equation, I know this will have 2 roots. What will be the 2 roots? X will be equal to minus of 2g plus minus square root of b square, that means 4g square, minus 4ac, 4 into 1 into c, that means 4c, divided by 2 into a, that means 2. Right? So this will become what? This will become minus g plus or minus square root of 4 will come out common, and 4 will be common and 2 will come out. 2 will cancel this 2, so this will become g square minus 4c, g square minus c, g square minus c. Correct? Minus g plus or minus g square minus c. So one coordinate will be minus g plus square root g square minus c, comma 0. Right? And other coordinate will be minus g minus square root of g square minus c, comma 0. These two coordinates will be there. Circle will be making the intercepts over here on x-axis. If I find the distance over here, what will be the distance? What will be the distance? It will get summed up. That means 2g plus, right? Sorry, not 2g. G and g to will get cancelled only. No, it will become 2 times of g square minus c. That will be the length of, let's say this is a, this is b. That will be the length of my x-intercept. Positive only if I am talking about length. Then this will be the length of my x-intercept. Correct? Otherwise, if a line is cutting, suppose here we were talking about a line. Na? If a line is making the intercept. So here what all can I do? First of all, I can draw a perpendicular. Right? This length I can find. This length so I can find because center will be known to me. center will be known to me, minus g comma minus f, for example over here I'm writing, but center will be known to me. From center I know how to find the distance of a point from the line. ax1 plus by1 plus c mod of divided by square root of a square plus b square, that formula I know from straight lines. If this I'll be able to find, I'll be knowing the radius also, right? Circle ka information to will be given to me na, I'll be knowing the radius also. If I know the radius and this distance, I'll be able to find this, and I'll double this because this is bisected. From center if I draw a perpendicular to a chord, then it will bisect the chord. Yes bete, definitely you should do the revision. Circle ka entire revision you can have in this lecture only, then you can directly solve examples or PYQs, whatever you want, right? So this will be bisecting. So suppose if it's not x-axis, by x-axis ke liye to, for x-axis we have derived a formula. For y-axis also x-intercept will be given by this 2 times of g square minus c, and y-intercept also we could derive the formula 2 times of f square minus c, it is going to come. Same thing will be applied and 2 times of f square minus c will be coming. But if line is given, then to you have to use geometry na, because bhai radius will be given to you, center will be known to you. Find this, apply Pythagoras theorem to find this, double this and find the intercept. Okay ji. So dekho, whenever a circle makes an intercept, on the line, this thing only is written. This is L by 2, this is L by 2. Something or the other will be given to you. For example, just now we derived this, right? On intercept made on x-axis will be 2 times of square root of g square minus c. And intercept made on y-axis will be 2 times of square root of f square minus c. Abhi g square, here sometimes prove that, or in what condition, they'll ask you a question like this, and in what condition the intercept made on x-axis is there is no intercept made on x-axis. Prove that this particular circle, or for what condition this particular circle will not make any intercept on x-axis. Then in that case, just this g square minus c should be less than 0. Correct hai ji? This g square minus c should be less than 0 in that case. If you want it should be x-axis should be a tangent to my circle, then g square minus c should be equal to 0. Okay, then g square minus c should be equal to 0. If you want x-axis to be a tangent for a circle, then just put g square minus c to be equal to 0. If you want x-axis if you want two intercepts to be there, then g square minus c should be equal to greater than 0. For what condition this particular circle will cut the x-axis at 2 different points? Either 1 point or 2 different points, or won't cut. Only 3 scenarios can be there. A circle cannot cut at 4 different points. It's not a parabola, it's not even parabola won't cut. It's not a cubic polynomial or something, right? 3 different points. It's not a curve like this, right? So these are some small points which will help you in question solution. When you will derive these things, you study the chapter by taking every derivation or every formula as a problem. Then you'll be able to solve the questions. Otherwise, if you keep thinking that I should accept trigono, or I should say integration, standard integrations, I don't think in coordinate especially you have to remember anything. In PNC, coordinate, probability, and functions and all these type of chapters, you don't have to mug things up. You derive things, and that's how you'll be able to remember them. So that's my suggestion. That's it. On y-axis, same thing. The intercept made will be equal to 2 times of square root of f square minus c. Okay. Okay, let's take a simple question only over here. Let's take not x-axis and y-axis. Find the equation of circle. Find the circle means find the equation of circle, which is a center also will take, having center at 3 comma minus 1. Let's say our center is at 3 comma minus 1, and cutting intercept of 6 units on line. We should take carefully, otherwise calculation will increase. On 2x minus 5y plus 18, on 2x minus 5y plus 18 equal to 0. This type of question can be asked. It's a mains question only, right? Find the equation of circle whose center is at this and it is cutting an intercept of 6 units on this line. So by right, simple question. No, this is the circle, this is the line. Okay, 2x minus 5y plus 18, the question itself is saying that it is cutting an intercept. So that means line is cutting the circle at 2 different points. What will we do? We'll take radius as d, radius let's say is r. We'll take this distance as d. This point is given to us 3 comma minus 1. We'll find the distance of perpendicular distance of this point from this line by the formula 2 times 3 minus 5 times minus 1, that means plus 5, plus 18 divided by square root of a square plus b square, that means 4 plus 25. So square root of 29. This distance will be there, correct? How much it will come? 10, 15 plus, minus 18 hai, plus 18 hai. I think it should be plus 18 only. 6 plus 5, 11. 29 divided by root 29 only is coming. Okay, 29 by root 29 only is coming. So it will become root 29 only, na? So distance, this d is equal to root of 29. Correct. Now center, this is given to me. This point can I take? Next step should be what? Equation of circle ke liye I have circle, I have center and I need just radius. For that I have one thing. I have this entire intercept is of 6 units. So this will be of 3 units, this will be of 3 units. This is root 29. Right, this is root 29. So r I can find. R square will be equal to 9 plus 29. 3 square plus root 29 square. So r square will be equal to 37. 38. Right. So r will be equal to root 38. I have the point, I have the radius. So x minus 3 whole square plus y plus 1 whole square equal to square root 38 whole square, that means 38. This will be my equation of circle. So this question won't be difficult. Okay, x and y intercept derivation which we saw just now, 2 into x h square minus c and 2 into under root of h square minus c and 2 into under root of f square minus c. These two formulas which we saw, right? These can be sometimes important because these are minute things which we will actually forget and start deriving and start thinking, array, how will this happen? Line we will remember. This type of problem we'll be able to solve because once, right? But if they want to make a question, no, they'll make an easy question difficult on this particular concept. You will see in PYQs, when we'll be solving PYQs next week, you'll see they have made questions on this. And students are just jubbling, array yaar, what happened? They start deriving and they start thinking. Okay. So, alright. Anyway, we'll not do that. We'll be practicing very well. Acha, now comes tangents and normals. Before that, I'll just take a very small break. Okay. Because today I have bad back pain because of carrying my daughter for almost half kilometer. You know Godi, right? Godi, you don't know? My daughter is like some 3 years old and 2.5 years old, and these type of kids, you know, always will be fond of coming into Godi. We'll have to carry like this in malls or somewhere. That's what gives you backaches. So now you understand why your fathers and mothers started having backaches. The reason is you guys. Okay, let's look now. Now some standard notations. Standard notations, why they are there, that I'll explain you first. So suppose hello, voice is there, no? Everybody goes off if as I take break. No patience only, da. Now suppose I have a circle, right, and I have this point. Now this point is, let's say, x1 comma y1, and my circle is x square plus y square is equal to a square. Okay, general circle with radius a and center at 0 comma 0. Now what I want to check the position of this point with respect to circle. I want to know whether this point is inside, outside, or on the circle. So what will be my approach towards checking this? Center I know 0 comma 0. I know if this point is outside the circle, then the distance of this point, this distance, will be greater than radius of the circle. Okay, greater than the radius of the circle. So what will I do? I'll check the distance. Distance will come out to be x1 minus 0, square root of x1 minus 0 whole square, plus y1 minus 0 whole square. Correct? And this distance I want to be greater than radius, which is a. Correct. So I'll square both the sides and I'll say, okay, x1 square plus y1 square should be greater than a, and I'll say x1 square plus y1 square should minus a should be greater than 0. Sorry, a square. But when I see this, what did I get? I got the same equation of circle. What is this? X square plus y square minus a square. Same thing. Instead of x and y, I have just put x1 and y1. So to check the position, now suppose my point was on the circle. So what will I get? X1 square plus y1 square minus a square equal to 0, because this point will satisfy the equation of circle. Correct. If I put less than a, that means this point is inside. So I'll get x1 square plus y1 square minus a square less than 0. So instead of saying differently, and I'll just say that let's make a notation. My s is what? My s is x square plus y square minus a square. This is my s. This is my s, right? This is equal to 0 right now. So I said that, okay, let me define some s standard or s as something. Okay, s is something, some alphabet I gave that, okay, this is my s, which is the standard equation of circle written all things in one side. And then I said, okay, s1 equal to 0 means s1 equal to 0. S1 means x1 square plus y1 square minus a square. This is my s1. So now I can say, if my s1 is greater than 0, then my point is outside. If my s1 is equal to 0, then point is on the circle. If my s1 is less than 0, then my point is inside the circle. So that notations which we learn in many books, s equal to 0, t equal to 0, are nothing but transformations of the equations. Right? These are nothing but transformations only. Right? Nothing major about it. These are just transformations. We are transforming our equations with respect to some point, because eventually we are getting same condition, same thing in form of some different. Instead of x and y, we are replacing things. Derivations are same only. Right? Now suppose, now second thing, let's say I want a tangent. I want to check for tangent. Let's say I want that at this point I want a tangent. This point is, let's say, some first thing, that I want a tangent of slope m. I want that my tangent should be of slope m. Right? So what will be the equation of my tangent? Equation of tangent will be y is equal to mx plus c. And let's say my circle, I'm taking general circle only. You guys can derive on your own for minus f and minus g also. Same approach will be there. Right? Only results will be different. Results will be different means, in results, instead of x and y, x minus h or x minus g and x minus h, those things will come. Nothing major. If center changes, like center is at x1 y1, so instead of x you will have x minus x1. That's it. Nothing major. So here what will happen? Suppose center is 0, 0, and I want on this circle, I want a tangent of slope m. I want a tangent which should have the slope m. So that tangent's equation I know how to write. Y is equal to mx plus c. Now I know one more thing, that if this is tangent, then this angle will be 90 degree and this distance will be of 90 degree. Thoda sa, let me make it like this. This will be perpendicular distance, right? 90 degree and all. You know, from center, if we join the tangent, a point of contact of tangent, that will make 90 degree. That means from center it is perpendicular to this tangent. And we know how to find the distance of a point, perpendicular distance of a point from the line. We have learned that. What will we do? We'll write this equation as y minus mx minus c equal to 0. Distance of this line from 0, 0 will be what? 0 minus c, right? Mod of minus c, let's say mod of c only, divided by, even if we'll take mod of minus c, it will not make a difference, divided by square root of coefficient of x, that means m square, plus coefficient of y square, that means 1. 1 square means 1 only. So this distance is equal to this, and I know that this distance will be equal to r, right? If this line is a tangent, then this distance will be equal to radius. So I'll make it equal to r. For c, mod c, what will I get? R into square root of m square plus 1. That means c is, even if we had minus c, then also c will be equal to plus minus of the c. So don't worry about taking minus c, sir. Minus c it is coming minus c, but c also is fine. So c will be equal to plus or minus square root of m square plus 1, and here we have r into square root of m square plus 1. So equation of tangent which is of slope m will be nothing but y is equal to mx plus r into square root of m square plus 1. This will be the equation of tangent which will have slope m. Okay, now let's take, now I want a tangent which is whose point of contact. Now this time what I want a tangent whose point of contact is given to me. x1 comma y1 is the point of contact given to me, and center again I am taking as 0 comma 0. Okay, center again I am taking as 0 comma 0. But this time I want the equation of that tangent whose point of contact is x1 comma y1. So take this also as a problem. I know any line passing from x1 comma y1 can be written as y minus y1. Y minus y1 equal to m of x minus x1. कुछ तो problem है, right? I know equation will be y minus y1 equal to x minus x1, m into x minus x1. What will be m over here? Sir, m, sir, this slope, this line which is y equal to mx plus c, right? This line which is y equal to mx plus c, the slope of this line will be negative reciprocal of this line because these two are perpendicular. So what is the slope here? y1 upon x. What will be the slope here? Minus x1 upon y. Slope of this is y1 upon x. So slope of this should be minus x1 upon y. So that the product becomes minus 1. Product of perpendicular lines, slopes of perpendicular lines. So y minus y1 will be equal to minus x1 upon y into x minus x1 I can write. What will this become? y1 y1 minus y1 square equal to x1 plus x1 square. Bhai, why does this start creating problem for me? I don't know. I'll have to check with the technical team. y1 minus y1 square, let's shift everything. So y1 plus x1 equal to x1 square plus y1 square. Correct? Abhi x1 and y1 lie on the circle. What is the equation of circle that I took? X square plus y square is equal to r square. Correct? Equation of circle whose center is at 0, radius is r. So I took this as this. Now point is x1 comma y1. What am I getting? I am getting x1 plus y1 equal to x1 square plus y1 square. If I satisfy, this point lies on the circle, so this point will satisfy the circle. X1 square plus y1 square will be equal to r square. So x1 square plus y1 square, I'll write r square over here. What am I getting? I'm getting x1 plus y1 minus r square equal to 0. So this is what did I get? I got the equation of circle. Oh sorry, I got the equation of tangent. This is equation of tangent. R square is a constant, right? This is a line's equation, 1 degree. I got equation of tangent whose point of contact on the circle is x1 comma y1. But what is the change here? This looks like equation of circle only. Instead of x square, I have written xx1. Instead of y square, I have written y1. So this is again a transformation only. I have transformed my equation of circle by putting x1 instead of x square and y1 instead of y square. Now chalo, let's say that no sir, this to you did for the circle which is passing, whose center is 0 comma 0. Even if you take x1 comma y1, what will happen? Let's see. And let's take center is x1 comma y1, and let's take a tangent passing from x2 comma y2. Tangent to this, I want the equation of tangent to the circle whose center is x1 comma y1, and equation of circle is x minus x1 whole square plus y minus y1 whole square equal to r square. This is the equation. Center I didn't take at 0 comma 0. So what will we get? Same thing we'll do. I want a tangent whose point of contact on the circle with center x1 comma y1 and radius r is x2 comma y2. So what do? I write the equation of line passing through x2 comma y2. I know how to write that. Y minus y2 equal to m x minus, bhai sahab, why does this happen? I'll have to find it out. X minus x2. Okay. So y minus y2 equal to what will be m? What will be m? Do I have another stylus or pen over here? No, I don't have. Okay, anyway, what will be m? Slope of this multiplied with slope of this should be equal to -1. What is the slope here? y1 minus y2 divided by x1 minus x2. So slope of this line will be minus of x1 minus x2 divided by y1 minus y2, minus of x1 minus x2 divided by y1 minus y2. This will be the slope of line because it's perpendicular to this, into x minus x2. When we will solve this, what we will get? X x2 plus y y2 will get x x2. What solution will be different? Wait, I'll tell you because I know. This will be x square plus x1 square minus 2 x x1 plus y square plus y1 square minus 2 y y1 equal to r square. Okay. Same equation I'll get. Instead of x, I'll have x x1. Instead of x square, I'll have x x1. Instead of y square, I'll have y y1. Instead of x1, I'll have x plus x1 by 2. Instead of y1, I'll have y plus y1 by 2. That's it. Same equation I'll get. You can check. I'll get x x1, sorry, x x2 because it is passing from x2, right? X x2 plus x plus x2 divided by 2 whole square. Same thing I'll get, right? This pen is not working. Let just give me a moment. I'll check. Just give me a moment. Okay, I don't think anybody is here right now. So y y1, let's solve. Y y1 minus y y2, y y1 minus y y2 minus y1 minus y1 y2 plus y2 square, right? This side what we'll get? Minus of x1 x minus x1 x2 minus x2 plus x2 square. Correct? This is what we are going to get. So if we adjust things over here, we'll get y1 plus x1 minus y1 y2 minus x1 x2 and minus plus x2 square plus y2 square. इधर ये y1 y2 हो गया and y1 y2 came. Wait, did we do some jhamela kya? No, because this pen is rubbing everywhere, so I hope we didn't make any confusion. Minus x1 x2 correct है, minus y1 y2 correct है, x2 we didn't take, हाँ x1 we took, y1 we took, x1 we took, x2 तो won't come only na. Where did x2 come from? Minus x2 will also come, minus y2 will also come, minus y2 and minus x2 minus x2. These things will also come. But if we compare it with the normal equation, what we have done, instead of x1 we have just put x1, sorry, instead of x square we have just put x1, instead of y square we have just put y1, instead of x we have put x plus x1 by 2. When we'll take common, we'll get x plus x1 by 2. X will come common here and here, right? So x plus x1 by 2 instead of x, instead of y plus y1 by 2. So that is why equations are generally given as s equal to 0, t equal to 0. Right? Equations, you will see equation of point of chord of contact will be equation of tangent which has this point of contact is equal to t equal to 0. T equal to 0 is nothing but some transformations. So instead of deriving this, you remember these transformations, simple transformations which we can remember is any second degree, that is this represented as s equal to 0. So s equal to this. Okay, fine, leave it. So consider a point x1 comma y1. Value of s is represented by s1, right? S1 is nothing but this. In same equation, instead of x, if you put x1, that is s1. In same equation, if you replace x square by x1, y square by y1, x by x plus x1 by 2 and y by y plus y1 by 2, this we don't need, then you will get t equal to 0. This will be your t. So normal equation, circle's equation is x square plus y square plus 2gx plus 2fy plus c. Replace x square by xx1, y square by y1, x by x plus x1 by 2 and y by y plus y1 by 2. You will get t. This will be denoted as t. So instead of writing big equations and remembering, these notations are remembered. These notations only are remembered and nothing else. Now, first thing which we studied, finding a distance of point from center. So instead of doing this, although we know that suppose the point is P, center is O, then if my OP is greater than R, point will be outside. If my OP is equal to R, then point will be on the circle. If my OP is less than R, then point will be inside the circle. Do I need anything to remember in this? No. But this is useful, right? If point is given to you, find S1. Just now we did, na? We actually, what did we do? Here. What did we do? We found S1. Right? We found S1 only. So if my S1 is equal to 0, point is on the circle. If my S1 is less than 0, point is inside the circle. And if my S1 is greater than 0, then my point is outside the circle. Simple thing. This way it is better to solve the problems instead of finding these distances. Or we'll have to find the distance. Suppose center is given, suppose center is not given to me, radius is given to me and the point is given to me. Suppose I want to check whether 2, 3, the point 2, 3 lies outside, inside, or on the circle. Circle's equation is given to me, although I can find the radius also from there and center also from there if circle's equation is given to me. But still, what will I have to do? I'll just satisfy this point in the equation of circle and check whether I'm getting greater than 0 or less than 0 or equal to 0. That will be the better way. Suppose I want to check whether the whether x square plus y square plus 2x plus 4y plus 7 equal to 0. This is the equation of some circle. I want to check 2, 3 is inside, outside, or on the circle. What will I do? I'll just satisfy this in the circle. 4 plus 9 plus 4 plus 12 plus 7. If this is coming equal to 0, then on the circle. But obviously here we took everything positive, so it has to come greater than 0. That means this point is outside the circle. Simple, right? If this value came equal to 0, that means point is on the circle. If this value comes greater than 0, point is outside the circle. This is what we checked. Then distance, least distance and greatest distance. One concept is, although this is not a concept, this is a problem only again. By least distance means, if I want the point to be at least distance from the circle, like least distance of point P from the circle. What will be the least distance of point P from the circle? Least distance from the circle, from the center of circle. No, not the center of the circle, from the circle. So if I want least distance, then OP plus R. If I shift this point P and this OP plus R, if maximum distance will be, what will be the maximum distance? If this point is here, right, and distance is R plus this, right? OP plus R will be the maximum distance. OP plus R will be the maximum distance and OP minus R will be the minimum distance, right? Minimum distance will be when point is here. That means this distance OP minus R. If I do minus R, then it will be at minimum distance from the circle. Distance of point plus R if I do, then point will be at maximum distance from the circle. And if distance of point minus R I'll do, that point will be at minimum distance from the circle. So this is not a topic, this is again a problem only. Maximum distance and minimum distance of a point from the circle, right? Now, tangent, right? Tangents we saw. Position of line with respect to circle. Position of a line with respect to circle. Simple thing, I know how to find the distance of a point from the line. I know how to find the distance of a point from the line. So if this distance is less than radius, if this distance is less than radius, that means line is a chord. Line is forming a chord inside the circle. That means line is cutting the circle at two different points, right? If this distance is equal to radius, that means line is tangent to the circle. If this distance is greater than the radius, that means line is not touching the circle. It's outside the circle. So I know how to find this distance. Suppose I'm talking about a line which is this, y equal to mx plus c. Y equal to mx plus c. Okay, I know how to find the distance. Let's say this is 0, 0 only. Let's take general case 0, 0. Right? If I can simply see that my c, this will be the distance mod of c divided by square root of m square plus 1. If this is equal to r, that means this line is my tangent. So c, that's why c came out to be r plus minus r square root of m square plus 1. For tangent, the equation which we wrote, y is equal to mx plus minus r square root of m square plus 1. This is what we wrote, right, just now. Why did we write this? Because we made it equal to r. If I want the condition that the line is inside the circle, it is cutting the circle at two different points, then what will I do? I'll say, okay, c divided by square root of m square plus 1 is less than r. Less than r means c by square root of m square plus 1 is between minus r to r. When I'll open the mod, I'll get this condition. Correct? So this is how I'll have to relate the problems with the concepts. Nothing major. Okay. This distance, if d is less than r, then line cuts the circle. If d is equal to r, line is tangent. If d is greater than r, line does not meet the circle. So when we'll solve PYQs, we'll keep in mind these concepts. Instead of formulas, main thing is that we'll keep in mind these concepts. Some things we'll remember. For example, method 2. One more thing which we can do. What we can do is, we can solve the line with the circle. Suppose my circle is x square plus y square is equal to r square. And my line is y is equal to mx plus c. And now what I can do, I can solve this line with the circle. I'll replace y as mx plus c. So what will I get? X square plus mx plus c whole square equal to r square. Correct? I'll get this. Now, when I'll solve this, what will I get? X square plus m square x square plus c square, right? Plus 2mxc equal to r square, right? Whatever. I'll get either line or equation of circle. One of the thing I'll get, and some things also I'll get. What I can do, I can solve the line with the circle, and there the quadratic equation which I'll form, there I'll make that if my discriminant of that quadratic equation which I'm making, if the discriminant of that is greater than 0, that means I'm getting two distinct roots. That means my line is cutting the circle at two different points. If there I'm getting discriminant equal to 0, that means line is the tangent. If I'm getting discriminant less than 0 of that quadratic equation, of this quadratic equation, then what will I do? I'll say that my line is not touching the circle. Right? So in this quadratic equation only, which is x square 1 plus m square plus 2mcx plus c square minus r square. This is my quadratic equation. And in this, my discriminant, what will be my discriminant? Discriminant will be 4m square c square minus b square minus 4a, that means 4 1 plus m square, a and c, which is c square minus r square. This discriminant is coming greater than 0, that means line is cutting the circle at two distinct points. If this discriminant is less than 0, line is not touching the circle. Equal to 0, that means line is tangent to the circle. Nothing major, no problem in this, right? So these are just ways written how to check the position of line. It depends on what things are given to you in the question. Concept, you know, it's straight line concept only. Nothing different we are doing. Straight lines concept only we are using. So, but yeah, small things which you need to remember is an equation of tangent having slope m on this circle. This is for, remember, this equation is for circle whose center is 0, 0. If your center is different, no, then equation is different. That also I'll show you. But if your circle has center 0, 0 and radius equal to r, then the equation of slope m, equation of tangent with slope m will be simply given by y is equal to mx plus or minus two tangents will be there, no, of slope m, right? There can be two tangents of slope m. Both the tangents are having slope m. Two parallel tangents can always be there. Two parallel tangents will be there. So there will be two tangents, plus and minus. That's why plus and minus. There will be two tangents of same slope. By any circle, if you make tangent over here, then same slope tangent will be over here also, right? If you make tangent over here, then same slope tangent will be here also. So that is why two lines will be there of same slope to a circle, okay, of same slope. But this particular thing you should note down and remember, because this we will not be able to derive every time. And if the center is x1 comma y1 and the circle is x minus x1 whole square plus y minus y1 whole square equal to r square, or the general form where you can derive the center minus g comma minus f, then in that case you derive the center and this will be your equation, y minus y1 equal to x minus x1, m into x minus x1 plus minus square root of, this thing remains same, r into square root of 1 plus m square. This thing remains same only. For example, tangent to this circle having slopes 3 will be equal to y is equal to 3x plus minus r. What is r? R is 2 square root of 1 plus 9. That's it. Simply you can write. No, this is wrong, right? This mistake will happen. Check the center. Equation will be that this equation was for center 0, 0. Here center is different. Center is what? 1, 5. So your equation will be y minus 5 is equal to mx minus 1 plus or minus 2 into square root of 1 plus 9, 1 plus r square, that 1 plus m square. So that is m is 3. Right? Here also you'll have 3. This will be the equation of your tangent of slope m on this circle. Okay, one more thing. One concept is taught, but it is actually the application of what we learned just now. They are saying that two tangents which are perpendicular to a circle, find the locus of two tangents which are perpendicular to each other and they are tangents to the same circle. That means there is this tangent, there is this tangent and there is this tangent, and both are perpendicular to each other. And circle is let's say x square plus y square equal to a square. Okay, circle is also given to me. I think we should take a problem that will be better in this case. Let me think of or look for a problem. Just a minute. Or chalo, let's take x square plus a square, y square plus is equal to a square only. Not a problem. Center is 0, 0. No problem. What are we saying? That two tangents are find the locus of tangents which are perpendicular to a given circle. That's the problem. They call this locus as director circle. I'll explain. This problem will explain what is the meaning of director circle. Now, if these two tangents are perpendicular to each other, that's what the question says, that both of the tangents are nothing but perpendicular to each other. So in this case, what will we take? We know, let's say this slope of one of the tangent is m. Okay, we know how to write the equation of tangent from point x comma k, h comma k. That will be y minus k equal to m h x minus k, x minus h. Okay, this will be the equation of that tangent. Now this I know over here mx, if I solve this, y minus k will be equal to mx minus mh. Correct? So y minus mx equal to a minus of mh plus k, or k minus mh, better, k minus mh. Correct? And one more thing I know, that equation of tangent, this is one way of writing the equation of this tangent. What is the other way? I know how to write the equation of tangent which is having slope m. Y is equal to mx plus or minus r, or r is a over here, na? We took a, plus or minus a times square root of 1 plus m square. So that means this value and this value are same. Correct? This value and this value are same. This way also I can write, no, over here y is equal to mx plus k minus mh. Same thing, no? So k minus mh, my k minus mh is equal to this, a square root of 1 plus m square. If I square both the sides, I get k square plus m square h square minus 2k m h equal to a times of a square plus a square m square. Now what am I getting? I'm getting a quadratic in m, where m square, if I take common, I get 1 minus h square, right, and plus minus 2 k h m plus k square minus a square. This is what I get, equal to 0. This is a quadratic in m, and I know m will have two values. The product of two values of m will be equal to minus 1, because these two tangents are perpendicular to each other. So the roots which I am going to get from here, the product of those roots will be equal to minus 1. What is the product of roots of a quadratic equation? It's nothing but c by a. So k square by minus a square divided by 1 minus h square will be equal to minus 1. What am I getting? I'm getting k square minus a square equal to h square minus 1. So this is what? So, something wrong. C by k a उल्टा कर दिया क्या हमने? We did something. H square. Wait. M square h square correct है. Minus this also. Wait. This should not come like this. K minus mh correct. Mx minus mh. So y minus mx, y is equal to mx plus k minus mh correct. K square minus a square on a square minus h. M square common. Arey. We did wrong here. This will be h square minus a square. Right? So here we'll get h square minus a square. Here we'll be having h square minus a square. Product of slopes c by a, h square minus a square. So here also we'll have a square. What will get? K square h square minus a square. Correct था ना भाई? क्या गड़बड़ कर दी? Equal to minus 1. So this will have minus. So k square plus h square is equal to 2a square we'll have. Correct. So locus we are finding. So we'll replace this with nothing but x square plus y square equal to 2a square. We got the same equation of circle. Only difference is that here instead of a we have 2a. If the radius of this was a, radius of this is root 2a. So locus of the point of intersection of perpendicular tangents to a circle is nothing but another circle whose radius is root 2 times the radius of the given circle. And this is only called director circle. This concept what they call is director circle. Director circle. Maybe, I don't know what's the reason why they call director circle, because it's syncopic from outside. Anything can be the reason, but this circle is called the director circle. We did nothing. There are other ways also in your books or in your classes. They can derive it with trigonometry also. You can derive this with trigonometry also. Not a problem in that case. But here I wanted you to see that you can always solve the line with the circle and check the condition for the line. It's a tangent, it's a chord, it's lying outside the circle, or whether it is perpendicular with another tangent. All the things you can do by solving the line with the circle. Line with the circle solving should be comfortable with you. For if you want to solve the questions. If you want to solve the questions, solving the line with the circle will always give you results. Be very confident with that. Don't rely on any formulas. Nothing if you are getting no, and you are solving a question which involves a line and the circle, solve the line with the circle, something you'll get. Be confident with that. If your discriminant is coming greater than 0, that means it is a chord equal to 0, it's a tangent less than 0, it's outside the line, outside the circle. So this concept only was written over here. Locus of the point of intersection of perpendicular tangents to a circle is called director circle, and its radius is root 2 times. If the radius was a, the radius is root 2a over here in the director circle. right? No different, no major concept, simple concept only. For example, director circle of this circle, director circle of this particular circle will be same circle, its radius, the radius over here is root 3, r square it is root 3, so root 2 times root 3, the radius of this same circle will get, radius will become root 2 time of root 3, which will be root 6, root 6 square will be 6, right? So director circle mein radius will be root 2 times the circle of root 2 times the radius of the given circle and nothing else. Okay. The other things which we learned just now, if there is a tangent whose slope is m, then that tangent's equation can be written as y is equal to mx plus minus r into square root of 1 plus m square. If the point of contact is x1, the equation will be nothing but x1 plus y1 minus r square equal to 0. Right? If you want to write it in the normal form, like equation is something like this: x square plus y square plus 2gx plus 2fy plus c equal to 0. Then here just instead of x square you have to put x1, y square y1, x instead of x you have to put x plus x1 divided by 2, and instead of y you have to put y plus y1 divided by 2 plus c equal to 0. These concepts learn very carefully, very efficiently. Circle is a straight line and circle combined itself complete half of the coordinate geometry. Nowadays parabola, ellipse and hyperbola questions are very less after 2023, from 2023 only it's in fact, right? So practice these. This thing, same equation, right? Here point of contact is what? P theta means parametric point. What is the parametric point? Parametric point is r cos theta, r sin theta. That is the parametric point. So in this equation, x square plus y square is equal to r square. Instead of x you put x1. What is x1 now? Point is r cos theta. So x r cos theta plus y r sin theta equal to r square. When you'll do, what will you get? R will come common, so it will become x cos theta plus y sin theta, right? R will cancel, 1 r and equal to r, same thing will come. So tangent passing from tangent whose point of contact is given in parametric form, then this will be your tangent and nothing else. Probability and statistics chapters for 25. Statistics I'm planning to take. Probability I think it will take till 10th of January. Probability also I'll take, but statistics I'm planning to take sooner. Okay. Now common tangents. This is actually geometry, right? Common tangents topic is nothing but basic geometry, right? For example, if two circles are apart, right, are not touching each other, so you can see how many common tangents can be there. One tangent will be this, one tangent will be this, one tangent will be this, one tangent will be this. What will be the condition in this case? The distance between C1 C2 will be greater than R1 R2, R1 plus R2, right? Distance between C1 C2 will be greater than R1 plus R2 in this case. If this is the condition, then there will be 4 common tangents if circles are not touching each other. If circles are touching each other, then there will be 3 common tangents. And in this case, distance between C1 C2, the two centers, will be equal to R1 plus R2. Correct? In this case, only 2 common tangents will be there. Third common tangent cannot be there. And the distance between C1 C2 will be less than mod of R1 minus R2. Correct? Or lesser than R1 plus R2. No, here we should use R1 plus R2. R1 plus R2. It will be lesser than R1 plus R2, na? Correct? And in this case, only one common tangent can be there. In this case, only one common tangent can be there. Right? Obviously, there cannot be other tangents. So in this case, what we will do? Distance between C1 C2. This distance will be even lesser than this distance, C1, C2 distance wouldn't it be even lesser than R1 minus R2? Correct. And in this case, same thing. So these conditions, right? In this case, the distance between C1 C2 will be exactly equal to, not less than, exactly equal to R1 minus R2. And in this case, it will be even smaller than R1 minus R2. Right? Mod of R1 minus R2. Mod, you'll have to remember, obviously, because we are talking about distance. So just revise this once again. Right? Basic conditions, general basic aptitude also, if you'll apply here, no, you can remember these. You don't have to remember that if circles are not touching each other, 4 common tangents will be there. If circles are touching each other, 3 common tangents will be there. If circles are crossing each other, then there will be 2 common tangents, and condition will be this. Acha, mod we have applied. So less than R1 plus R2 and greater than R1 minus R2. This also is correct. Obviously, it will be less than R1 plus R2 and greater than R1 minus R2. Mod of R1 minus R2. Both you can use. You can use this side also, this side also. Right? Depends on radius. Correct? So, and here distance will be exactly equal to mod of R1 minus R2. And here distance will be even less than mod of R1 minus R2. Right? R2 is even smaller, no, over here. So these are the conditions. Same thing again. See, 4 common tangents, 2, 4 common tangents, 3, 2, 1, like this. In this case, this entire condition, you should remember, if 2 common tangents question come, then apply this only. That will be better. Right? Because it can be greater than mod of R1 minus R2. No? If one is greater, another is smaller, or one is smaller, another is greater, then both will be true. It will be greater than this also, and it will be lesser than R1 plus R2. Right? The distance between centers will be lesser than R1 plus R2 also. So question will come based on number of tangents. If 2 circles are having 4 common tangents, then simply put this condition. 3 common tangents, simply put this condition. Most important is this one, 2 common tangents. Right? 2 common, because in every case, number of common tangents is exact. In every case, number of common tangents is exact. Now from external point, if there are 2 common tangents on 2 circles, sometimes question will be like this, that there is an external point, and from that external point 2 common tangents are drawn to 2 different circles. Only this is possible in that case. Only this figure is possible in that case. And here you have to just use similarity. C1, C2, right? If you look at this, I'll make it. If you look at this triangle, the green triangle, and if you look at the yellow triangle, which I'm making over here, yellow triangle, these two will be similar. This will be 90, this will be 90. One angle is common. AA similarity, these will be similar. So C1P, this distance, divided by C2P, this distance will be, ratio of these will be equal to R1 by R2. Correct? This condition or some other condition, if the question is demanding, based on similarity only, these questions will be solved. In this case, if from a point, 2 different circles, if there are 2 common tangents transverse, these are called transverse common tangents. Right? These will be called as transverse common tangent. For these, I don't think any name will be there. Transverse and kya naam? Just a minute. Because they mention name generally in case of transfers only. No need to remember even transfers and external point, external tangents and internal tangents. I think this is enough. but generally for this they also use transverse tangents, right? These are called common tangents, but in this case if we want to define, these are called transverse tangents, means which are intersecting also. Transverse tangents means which are intersecting also. No need of name. This is external, this is internal. External tangents, internal tangents, right? From an internal point between the two circles, and external point which is outside both the circles. Both points are outside both the circles, but this is external point, from an external point, and they'll say internal point for this. No name is mentioned like that, but for these type of tangents they might use the word transverse. We'll see in the questions, don't worry about it. Okay, now length of common tangent. Length also no problem, simple Pythagoras theorem only we are applying. So suppose if I connect this point with, let me use the line. If I draw from here, if I draw a parallel line like this, okay, and if I connect these two, it will form a right angle triangle, correct? Now this distance, if you look at this distance, this is R, let's say this is R1, this complete is R2, so this is R1 and this is R2, so this distance will become R2 minus R1, correct? R2 minus R1 or R1, okay, this one they are calling as R1. Look, this is R2 because C2, and this is R2. This will be equal to R2 and this will be equal to R1. So this one will become R1 minus R2, right? In this particular triangle, if we see, this distance is what? C1, C2. C1, C2 means coordinates will be given. So simple Pythagoras theorem we can apply. Hypotenuse, that means length of tangent. These two are parallel now. So length of this and length of this will be equal. Hypotenuse square will be equal to R1 minus R2 whole square plus C1 C2 whole square. So hypotenuse square will be equal to square root of C1 C2 whole square minus R1 R2 whole square. That's it. Simple Pythagoras theorem is being used. You don't have to remember these. You can derive and form these at the time of question also. Too much of remembering is also not good. Some things will have to derive, right? Here also you can do the same thing. Here you draw a parallel line like this. So this will form a triangle, right? This length you can find, and here you can connect. Here you can connect, right? So now your Pythagoras, now your right angle triangle is this. So this length square will be equal to this. This length, which will be how much? R2 plus R1. No, wait, I did wrong. Wait, I did wrong. Not this triangle. This triangle won't help. This triangle will help. This triangle will help. This triangle will help. So this is 90 degree now, right? Now you can find the length of this. This will be C1, C2. This length will be C1, C2. And this length will become R1 plus R2. Right? This length will become R1 plus R2. So length of hypotenuse will be equal to this plus this, which is given over here. Right? So length of this tangent which we need will be this minus this. That means C1 C2 whole square minus R1 plus R2 whole square, and obviously square root over that. Chaliye, chord of contact. Now comes chord of contact. Acha, main part or majorly the questions in this chapter come from line with respect to circle. So practice that part very carefully. Tangent equations. Tangent, three forms only. One is slope, y is equal to mx plus or minus r square root of 1 plus m square. Second is point of contact x1 y1, then t equal to 0 you have to do, x1 plus y1 minus r square equal to 0, or you know the transformations you can check. And parametric form, not that much. Then few questions come from chord of contact also. Very few questions come from chord of contact also. And for here also we have direct transformations. For example, if from external point, if there is an external point x1, y1, and we draw two tangents to the circle from that point, from that external point, then in this case, chord of contact means the chord which is connecting the point of contact of both the tangents. From an external point, if we draw two tangents to a circle, then chord of contact is called the chord which is connecting the point of contact of two tangents with the circle. So in this case also we can simply understand, suppose let me take this point as a comma b, and let's say this point is some c comma d. Okay, so this point is a comma b, this point is c comma d. Now what do I know? That both the points, I know how to write the equation of circle using point of contact. How will I write? Let's say this circle is x square plus y square equal to 0. This is s equal to 0. X square plus y square is equal to 0. Right? Let's say this circle is x square plus y square is equal to 0, is equal to a square. Correct? I know how to write the equation of tangent whose point of contact is a comma b. How will I write? x1 is a over here. So x a plus y1, that means yb minus a square equal to 0. This will be my equation of tangent. And similarly for c comma d also I can write xc plus yd minus a square equal to 0. Acha, what are these two? These are lines. These are not curves. These are straight lines. Look at the power of x and y. These are straight lines. If these are straight lines, these straight lines are being satisfied by point A and C. And obviously, if I put instead of these A, B and C, D lie on the circle also. So instead of x, if I put A, and instead of y, if I put B, I'll again get a square plus b square. Acha, A and B I shouldn't have used. Here I can use R. Right, here I can use R. A square plus b square is equal to r square, and a square plus b square equal to r square. That means these points are satisfying the equation of circle, and these points are also lying on the same line. These points are also lying on the same line. How is it possible? This is only possible. This is only possible if these points are on the same line, and same line means chord of contact. That's why we simply say chord of contact's equation is simply given by s equal to 0. S equal to 0 means instead of x I have to put x1 and instead of y I have to put y1. Right? This is also giving me a square plus b square minus r square equal to 0. Right? Same thing. So equation will be nothing but s equal to 0. So not s equal to 0, t equal to 0. Instead of x we are putting x1, instead of y we are putting y1. T equal to 0. Right? Equation of chord of contact is given by t equal to 0. I only derived and I am only saying wrong. Instead of x, what are we putting? xa. Instead of y, what are we putting? xb. And on this line, x1 y1 also lies. So x1, that means x1 plus y1 minus r square equal to 0 will also be satisfied. Right? On this line, this point also lies. Right? I wrote, what is this? This is the equation of my line. And instead of x1 y1 I'm putting, instead of a comma b, if I'm putting x1 y1, this is what I'm getting. So equation of chord of contact, simply remember, is given by t equal to 0. But sometimes confusion happens here. In this t equal to 0 is a transformation. Right? S equal to 0 is a transformation or substitution. Right? T equal to 0 with respect to this point. Now here also one catch is there. Now if I bring this point very close, suppose this point comes here, then also t equal to 0 is true. Because how do we write the equation of tangent whose point of contact is x1 comma y1? We write t equal to 0 only. We write t equal to 0 only. Thank you, Unicross. It's okay, na? You don't have to comment about it, bro. right? It's given by t equal to 0 only. If we make the point, if we bring this point very close on the circle, then also t equal to 0 will be true, because that's how we give the equation of tangent whose point of contact is x1 comma y1. So point of contact, instead of point of contact, we are throwing two tangents from an external point, and chord of contacts equation will be this only. And how do we get it? T equal to 0, where in t, point which is external to the circle, from there we are making the chord, right? Up now, equation of chord with given midpoint x1 comma y1. Here also we can do. Here we know, right? Center is 0 comma 0, for example. Let's take center 0 comma 0. Correct. Now also we can write the equation of this tangent. How? Slope we will know by this, and point we have. Slope will be what? Minus of x1 comma y1. Slope of this is y1 comma x1, so slope of this will be minus of x1 comma y1. Correct. And y minus y1 equal to minus x1 upon y1 into x minus x1 will give us t equal to s1. T equal to s1 means x x1 plus y y1 equal to x1 square plus y1 square. This is what we'll get when we'll do that. Simply remember majorly two things: chord of contact from an external point, chord formed by an external point which is throwing two tangent on the circle, and chord which is connecting the point of contacts of those tangents. That equation is written by t equal to 0 only, wherein t, instead of x we put x x1, instead of x square we put x x1, instead of y square we put y y1, instead of x we put x plus x1 by 2. Same transformations, right? Point is this. Again, you can remember this by this. If you bring this point over here, it becomes the point, it becomes a tangent. This will become a tangent, correct? And same thing will happen. A chord whose midpoint is x1 comma y1, its equation will be given by t equal to s1. Two major points. That's it. Now comes orthogonality. Orthogonality is not something which is a difficult topic. Sometimes, you know, it is given in the end, so we think, arey yaar, this is going to be more difficult topic, let's skip this, or this is not in syllabus or something. It's very simple major thing. Simple thing basically. By orthogonality means two circles are orthogonal, and two circles can be orthogonal if from their centers, if we draw the common tangents, if we draw the tangents and the intersection of these tangents come at 90 degree, or these two tangents are from the center of both the circles. If we draw tangents on the opposite circles, and though the angle between those tangents come out to be 90 degree, that means the circles are orthogonal. And in this case, mostly one concept, mostly 99% of the times one concept only is used, that one tangent, this tangent, this particular tangent will be normal to this, right? Suppose, leave this, let's say the line perpendicular to this tangent will be normal to our circle, and normal of a circle always passes through the center. Normal of the circle always passes through the circle, so most of the times this will only be used, right? If two circles are orthogonal, that means from one we are throwing a perpendicular tangent on the other one. This voice. Right? Or basically, if they if they want to define a condition, you think like this. If we think in the reverse way, right? I want that tangents to these circles, common tangents or point of intersection of tangents are right? Suppose if I draw this tangent, right? Tangent at this point of intersection of circles, if I'm drawing, arey yaar, diagram only is making problem. If I draw tangent to this, leave it. If I draw two circles like this, and I want tangents at the point of intersection of circles, that means this tangent and this tangent. Okay, now you think that, and orthogonality means that the angle between these two tangents should be equal to 90 degree. Orthogonal circle means at the point of contact of two circles, if I draw tangents and both the tangents angle comes out to be 90 degree, that means circles are orthogonal. Other way round of thinking is this, is that if this is the tangent and angle between them is 90 degree, then this tangent will be normal to the circle and it will pass through the center of this circle, and this tangent will pass through the center of this circle. This concept is used multiple times in these questions, that one tangent will be normal to the other circle. Tangent of one circle will be normal to other circle, right? And it will pass through center. Just remember that. That will help you a lot in solving the questions. Other two things which we can use, which we can deduce also, this angle will be 90 degree. So r1 square plus r2 square will be equal to d square. And here only, if we put the values of r is what? Square root of r is square root of g square plus f square minus c, right? C1, obviously first constant, plus square root of g1 f1, right? g2 square plus f2 square minus c2, right? Square of this equal to d, which is, this will be equal to what? If you add this, you'll get, if you add this will be equal to what? This distance, which is how much? This is g1, this is minus g minus f 1, this is minus g2 minus f2. This distance only we are talking about. So what will be this? Minus g2 plus f g1, that means g1 plus g2, g1 minus g2 whole square plus f1 minus f2 whole square. Correct? When we'll solve this, we'll just get this, because g1 square, g2 square, f1 square, f2 square will get cancelled. We'll get 2g1 g2 plus 2f1 f2 equal to c1 plus c2. c1 plus c2 small, this is small. These are constants of the equations. These are not these c1 c2. These are constants of the equation. In this equation only, we put the values of r1 and r2. R is g square plus f square minus c. So g1 square plus f1 square minus c1 whole square, g2 square plus f2 square minus c2 whole square if you put, and distance if you find. The centers are minus g minus f, minus g1 f1 minus g2 f2. So distance between them will be g1 minus g2 whole square and f1 minus f2 whole square. And minus g1 g2 will get added over here. Minus f1 f2 will get added over here. That's it. This is why we are getting this. g1 square, g2 square will get cancelled. Right? Okay. Right? Minus 2g1 g2 will come this side, minus 2f1 f2 will come this side, everything will get cancelled, and these c1 plus c2 will go that side. That's why c1 plus c2. So majorly, most of the times, this concept that one tangent will be normal to other circle. Normal means perpendicular to the tangent, which will pass through, and normal of the circle always passes through the center. This concept only itself will be enough to help you for the questions. If not, then these conditions. In these conditions, in the case when you are able to find radius and centers, if you are able to find radius and centers, then how you know how to, this approach will be used to prove that circles are orthogonal. Otherwise, you'll have to use this to find the center, or some condition is there in which a line is given, tangents equation is given, then you have to form its normal and it should pass through the center. So this concept you should remember, that this tangent will be normal to this circle and this tangent will be normal to this circle, and normals pass through the center of the circle. That if you remember, I think you won't need this. This very rarely, not rarely also, sometimes this also is used. This particular thing is also used. But in case when you know the radius and the centers of the circles. Alright. Now comes the last part, which is family of the circles. This thing is particularly this is not, I think now it is not in main syllabus, but for advanced you'll need this. And very simple, family of circle means if I give you if I give you a line, and I want all the circles which are crossing, for which this line is a chord. So this circle, this circle, this circle, these circles, so many circles will be there, right? Or if I give you a line and say that this line should be a common chord to all the circles. If I want you to make, if I want a line which is common chord to all the circles, so many circles can be formed, na? So many circles can be formed. All these circles are just called family of circles, just like we had family of lines. Family of lines, right? Two lines, all the lines which have same intersection point, which were family of lines. All the circles which have same common chord are family of circles. But in circles we have different families. In lines we had only one family. In circles we can have different. In lines also we had two families actually. All the lines which are having same slope are also called the family of lines. But generally it is taught that sir, ellipse when ellipse इसके बाद after this ellipse, नहीं, after this parabola beta, after this parabola, right? After parabola we'll take ellipse. Ellipse and hyperbola will take together, but after parabola only we can take ellipse, because you know in parabola some concepts are there which I want, but PYQs of circles I'll try that if I can finish in this week only, it will be good. I'm trying my best. Okay, but देखो, I'll tell you, see, for PYQs also, no, once revise all the concepts very thoroughly. That is why otherwise there was no need of these sessions. You know, straight line circles are already taken on the channel, but we are doing this again so that students who could not understand in a long lecture, small, brief, crisp, with derivations, with the conceptual knowledge, they can understand, they can feel more confident, especially for 2026 aspirants. So that is why these sessions are also there. Any circle passing through one circle and one line, all the circles which are crossing this line and this circle, there can be many circles, like this circle is possible, right? This circle is possible, this circle is possible. Many circles can be there who are crossing, who are intersecting this given circle and this line. There can be many such circles. There can be many dotted circles like this, right? Many dotted circles. The family of those will be written in this form: S plus lambda L. That means circles equations plus lambda times lines equations. That's it. Any circle which is passing through this circle and this line will be simply given by x square plus y square minus 2x minus 3 plus lambda times x minus 2y plus 1 equal to 0. All the circles will satisfy this for different lambdas. For different lambdas, all the circles which are passing through this line and this circle are going to satisfy this equation, right? Second is all the circles which are going to pass through the intersection point of two circles. Suppose one circle is s equal to 0, another circle is s dash equal to 0. So all those circles which are going to pass through intersection of these two circles will be given by s plus lambda s dash. That means equation of this circle plus lambda times equation of this circle equal to 0. Here lambda cannot be equal to 1, because if lambda is cannot be equal to minus 1, because if lambda is equal to minus 1, what will we have? S minus s dash equal to 0, right? That is the equation of common chord. S equal to s dash is the equation of common chord, right? That we cannot use. Common chord of s equal to 0 and s dash equal to 0 will be given by this. That's why in this case first family is of all those circles which are passing through one circle, intersection of one circle and one line, right? Common chord for all these, common chord is this only, right? So same equation, same thing will come, na? Same thing will come, right? So that's why here lambda cannot be equal to minus 1. Third family, all those circles which are passing through 2 points. Given points are x1 y1, x2 y2. Any circle which is passing through 2 points, let's say 1 comma 1 and 2 comma 2. Simple way to write this equation, I'll tell you, two steps are there. First, write the equation in diametric point. Just imagine, just assume that these two are end points of diameter. So x minus x1 into x minus x2 plus y minus y1 into y minus y2, that circle, plus lambda times the equation of line, which is joining these 2 points. Equation of line which joins these 2 points, you can easily write y minus y1 equal to y2 minus y1 upon x2 minus x1 into x minus x1, right? So if 2 points are given, suppose these 2 points are given, 1 comma 1 and 2 comma 2, first write the equation of circle assuming that these are endpoints of diameter. So x minus 1 into x minus 2 plus y minus 1 into y minus 2, this will be the equation of diametric form of circle, plus lambda times equation of line, that is y minus 1 minus y2 minus y1 minus y2 minus y1, that means 2 minus 1 upon 2 minus 1, 1 only, into x minus x1. This will be equal to 0, right? Equation of line will be y minus y1 minus y2 minus y1 upon x2 minus x1 into x minus x1. Here y2 minus y1 upon x2 minus x1, slope is 1 only. So this line, this is the equation of line, and this is the equation of circle, diametric form. This will represent family of all the circles which are passing through given 2 points. Because basically what are we writing? We are doing the first family only. But these are different ways of writing which you should remember. Family of circles, for those tangent point is given, tangent is point, all the circles for whom this line is a tangent, right, at the given point. Given point is also there. L equal to 0 is the line and x1 comma y1 will be the point. Family of all those circles for whose point of contact is fixed and tangent line is also fixed. All the circles for those this line is the tangent and point of contact is same. There can be many circles, right? This circle, this circle, this circle, so many circles can be there. All of those point of contact is same and line is same, tangential line is same. Just write point circle. Point circle means assuming this as the center. Point circle means assuming x1 y1 as the center. So x minus x1 whole square plus y minus y1 whole square. Point circle, 0 radius. Radius is not there. Point circle means 0 radius. Point circle means this is the center and radius is 0. X minus x1 whole square plus y minus y1 whole square. That will be the equation of circle, point circle, plus lambda times the line. Right? Plus in this one plus nothing. In this one plus nothing. Right? Just this. Any circle touching x1, x plus y plus 1 equal to 0, add this. Just point circle, x minus 1 whole square plus y plus 2 whole square plus lambda times this line and plus nothing. Only this. Acha, plus nothing anyway we are not doing. Plus lambda times this line. First thing only. Same first one, if you can remember now, you'll be able to remember all the 4. Only 4 forms are there for family of circles. Although family of circles nowadays have stopped coming, but for advanced you can expect these type of questions also, and previous PYQs before 2019, 2020 also, I think these type of questions used to be there. Again, I'm reminding you, those who have not enrolled for All India mock test series, please enroll for this series. This is happening for 2025 aspirants, very important thing. Again, I'll suggest enroll for this and check your capability in, check your chances in 2025 JEE mains attempt. Mains and advanced also, but mains, this is specifically for mains. All right, then revise all these concepts, especially the tangent forms, right? Tangent forms, specially revise correctly, and the different forms of writing, diametric form, slope form, all the forms of writing the circle. Family of circles also, all the 4 forms you can keep revision. And now we'll be solving the questions, a lot of questions. There also I'll keep explaining the concepts according to the need, but still I'd recommend that if you can revise the things once, it will be very beneficial and it will be very helpful. Next week or this week end, we'll be solving all the PYQs of circles starting from 2002 to 24, and this time I hope I will take lesser time because there are more formulas, not like straight lines. There are calculations, but here there'll be more formulas. All right, then keep preparing, keep having fun. That's all from my side. Conic section, yes beta, Nad, conic section also will be taking. Okay then, bye bye, take care, have fun, thank you.